Good morning, students. I'm audible. My screen is visible to everyone.
Yes, sir.
Yes. Correct. Okay, right, fine. So, welcome to the module 39, right? So, for the IC engine subjects, we are entering the unit 5, right? So, modern technologies. What are the modern technologies there in the IC engines, right? So, that modern technologies, about the modern technologies, we can see in the fifth unit of the IC engines, right? So, why we have to use or why we have to prefer the modern technologies in IC engines, right? So that's very important, right? So why we need a modern technologies means the main problem is the emission, right? So now we are in BS6 stage, that is Bharat stage 6, right? So that type of engines we are uh, going on. That type of engine will be going on in nowadays, right? So what is the challenge we have faced in the previous cases, that is the Bharat stage 1, 2, 3, 4, right? So before after the 4 we directly gone for the 6, right? Why? Because the emissions control, right? So for the general purpose, right? So for the general purpose we are using the IC engines for the transportation vehicles, marine ships, and some constructional equipments or agricultural machineries. We are using the IC engines, right? So the IC engines will be classified into two terms, right? One is the SI engine and the CI engines, right? So while comparatively, which one is a emission one? Either SI engine or CI engine? Anyone answer? Just a general question. Which engine will produce more emission? Anyone? Anyone?
Yes, sir.
CI, right? CI will produce more emission. Okay, right. So why the this type of engine will emit the emissions, most of the NOx and the spout formations, right? So while burning of the fuel, right? While burning of the fuel, right, we may get some exhaust gas, right? In that exhaust gas we have some the chemical composition, right? The chemical, due to the chemical composition, due to the chemical changes occurs in while burning of the fuel and air, right? So we can get some emissions, right? We can get some chemical composition, that is the particularly for the NOx, carbon dioxide, carbon monoxide, then the NOx and soot formations, and some particular matters emissions will be there, right? So we have to reduce the emission, right? We have to reduce the emission. Why? Because uh, by due to increasing the emission of the greenhouse gases, right? So the automobile engines, most of the automobile engines will produce the greenhouse gases from the engine itself, right? So for the emissions, right? So it is very harmful to the humans, as well as it is very dangerous to the environment conditions, right? So the pollution will be more, right? So we have to reduce the pollution, we have to reduce the emission, right? So for that we are going to modify some systems in our IC engines, right? So this due to this reason, right, due to this high emission, right, we have to go for new technologies, new research is going on, right? So for that's a main problem, right? So that's a main problem for the emission. We have to go for a new one, right? So we have to reduce the emission. That's our ultimate aim, right? Then the fuel economy, right? So uh, the fuel economy will be increased day by day. The fuel consumption will be increases day by day. Why? Because the vehicles will be more, and the engines, right? So the older engines, that is the SI engine and the CI engines will have, it will consume some more fuel, right? So it will consume some more fuel means it will emit more pollution, right? It will give more exhaust, right? So we have to reduce the fuel economy also, right? We have to reduce sorry, we have to reduce the fuel consumption also, right? So these two are the main problems, right? So these two are the main problems. So for that we are going for a new technology. So one is the main one, emission, and second one is the fuel economy, right? Then how we can overcome these two factors? Then how we can overcome these two factors, that we can see. நெட்வொர்க் இஷ்யூஸ் எப்பப்பா என் சைட்லேருந்து நெட்வொர்க் இஷ்யூ இருக்காப்பா? வாய்ஸ் பிரேக் ஆகுதா? அன்மியூட் அண்ட் ஆன்சர்.
கேக்குது.
என்னப்பா?
இல்ல சார், கரெக்டா இருக்கு சார்.
ஓகே ரைட் ஃபைன். இல்லை ஒருத்தர் மெசேஜ் நெட்வொர்க் இஷ்யூ போட்டாங்களா?
அது அவனுக்கு.
ஓகே ரைட் ஃபைன். ஓகே ரைட் ஃபைன். ஸோ due to this, right, due to this we have to develop a new type of the engines, right? So due to the emission and due to the fuel economy, right? So we have to control these two, right? So we have to, how we can control these two means we have to modify the engines, right? We have to modify the engines in the terms of to develop the clean technologies, right? To clean technologies in the automobile with the lower fuel consumptions, right? For that we have to give we have to develop many research is going on, right? So for that research, the first one we can see about the HCCI engines, right? So what is the HCCI engines, right? So our topic is the HCCI engine, right? The homogeneous charge compression ignition engines, right? So you can remember this one, right? Homogeneous charge compression ignition engines, right? Right. So what is the HCCI engine, right? So here it is, the homogeneous charge is compressed, right? Homogeneous charge is compressed, then it will be approaches to the auto ignition. It will be approaches to the auto ignition condition, right? So that type of engine is called the HCCI engine, right? The HCCI engine, that is a homogeneous charge is compressed, right? The homogeneous charge is compressed and it is approached to auto ignition. It will compress to the auto ignition. So here you can note this, the auto ignition will be there. What is the auto ignition? Anyone?
Automatically it fuels.
Automatically the flame will be propagates, right? Automatically the flame will be propagates, automatically the fuel will be ignites, right? So that temperature is called the auto ignition temperature. That temperature is called auto ignition temperature. That is beyond the self ignition temperature, right? So we have to compress the air fuel mixture in the full form, right? We have to compress, so the compression ratio will be somewhat slightly higher, right? So the slightly higher, then while compressing, what will happen here? The heat will be generated. That heat will be, it's above its self ignition temperature, right? So it will be beyond the self ignition temperature, so the fuel gets auto burn, the fuel gets auto ignition, right? So that type of engine is called the HCCI engines, right? So it is incorporated for the both engines, that is the SI engines and the CI engines, SI engine and the CI engine, right? So just we can see what is the special for the SI engines and what is the special for the CI engines, right? So here you can see in the SI engines we have to supply the air and fuel mixture through the carburetor, right? So through the carburetor, what will happen? The mixing will be somewhat good, right? So the carburetor do is, that job is, it has to mix the fuel and air in proper manner, right? The fuel and air will be in proper manner, it has to mix, right? So for the SI engines, we can get the well mixed air and fuel ratio, right? So we can get the good air and fuel mixed in the condition, right? So it will be mixed good, so it can minimize, right? if the fuel and air mixer will be somewhat good, so it will minimize a particular emissions, right? It will minimize the particular emissions, right? So further only the petrol engines will have low emissions while comparing to the CI engines, right? But the special for the CI engine is there is no throttling, right? There is no throttling losses, right? So why? Because we have to supply the injected, the we have to give the fuel as a injected format, right? So we have to inject the fuels, so it will leads the high efficiency if there is no throttling losses. So the efficiency is somewhat good, the efficiency will be in good, right? So why? Because it is a compressed ignited, it is compressed ignited, right? So for the special one is for the SI engine is, if the mixture is somewhat good condition, mixture is the air and fuel mixture will be somewhat good, right? So on the time what will happen, it will minimize, right? It will minimize the particular emissions, it will minimize the particular emissions, right? For the CI engines there is no throttling losses, so the efficiency will be high, right? So in HCCI engine it is combined, right? The SI engine and the CI engine principles will be combined, right? So in this SI engine you can see, right? So whether the diagram is clear, right? So in this diagram you can see here, uh, it is the diesel engine, right? It is a diesel engine. So here we have a fuel injector, right? Here we have fuel, right? So this is fuel injector, right? It is the fuel injector, right? Then here for the petrol engines, right? In the petrol engines, what is this? Anyone? Anyone? What is this? Just anyone answer. Unmute and answer.
Yes, sir.
What is this? This term?
Spark plug,
Spark
sir.
plug, right? So spark plug, right? So in the inlet wall of the SI engines, right? For the inlet wall of the SI engine, we have to supply the air and fuel mixture, right? Is it correct? In petrol engine, we have to supply air and fuel mixture, and for the diesel engine, we have to supply only the air, right? Only the air we have supply, and the fuel will be injected through the fuel injector, right? So while the combustion chamber, it is the combustion chamber, right? So in this combustion chamber we have the air and the fuel mixture, right? So all the combustion chamber will have the air and fuel mixture, right? So all the combustion chamber will have air and fuel mixture. Is it clear? Right. So for the petrol engine and diesel engine, how the fuel and air will get flame, right? So for the petrol engine, how the flame will be propagate? So once after the at the end of the compression stroke, what will happen? The spark will be produces from the spark plug, so the flame will be propagate. To the air fuel mixture, right? Is it correct? In petrol engines, you have seen the petrol engines how the flame will be propagates, right? So at the end of the compression stroke, right? At the end of the compression stroke, what will happen? The spark will be produces, right? The spark will be produces. That spark will ignite. The fuel. That spark will be ignite the fuel, right? Is it correct? In the petrol engines, right? So what about the diesel engine? So only the air will be passes in the in stroke, right? So the air will be passes, and at the end of the compression stroke, what will happen? The air will get some heated condition. The air will compress. So
Diesel inject out.
so the diesel will be injected, right? So while injecting the diesel, so it will be burns, right? So while injecting the diesel, it will be burnt, right? So here you can see the advantages and the disadvantages of the petrol engine and the diesel engine, right? So here the fuel will be sprayed, right? Here the fuel will be sprayed. In some conditions, what will happen means the spraying of fuel, spraying of the fuel will be accumulated in some other places, right? It will be accumulated in some other places. So what will happen if the accumulated will be more? It will create the knock, right? It will create a knock. Is it correct or not? Right? So if the fuel will be accumulated in some places, what will happen? So it will be creates the knocks. So it will create the abnormal burning, right? So due to the abnormal burning or due to the combustion of the fuels, right? So here you can see, right? So while in the diesel engines where the flame will be gets ignited, where the fuel gets ignited, so there we can get the hot flames, and there we can get some knocks and the smoke. So the emissions will be producing there itself, right? So while burning off the fuel, right, while burning off the fuel, right, where the hot flame will be propagates, right, so there the emission will be creates, that the emission will be produces. Is it clear? So for the petrol engines, where the fuel will be burned, so here, right, so from here, so it will have some region, right? So in that region, what will happen? The hot flame will be propagates. The flame will be propagates. So there the NOx will be produces. There the NOx will be produces. Right? Is it clear? So there the NOx will be produces. But in HCCI engine, you may note this one. We are not using the spark plug. We are not using the fuel injector. Right? So here we are not using any additional devices, right? Here we are not using any additional devices. So only the inlet valve and the exhaust valve will be there. So here we can supply the air fuel mixture. Right? So once during the suction stroke, what will happen? The piston will be moved from TDC to VDC while in the suction stroke, right? While in the suction stroke, what will happen? The charges will be comes into the combustion chamber, right? So here the air and fuel mixture will be there, right? So while compressing, what will happen? So the air and fuel mixture will get the high pressure, also it will get the some high temperature also, right? So here you can see if the fuel mixture will be rich, right, on the time the flame will not be propagate easily, right? The flame will not be propagate easily, but the fuel will be somewhat low condition, that is the lean mixture. If it is in lean mixture, so what will happen? It will be burned in easy manner, right? It will be burned in easy manner, right? So here in the homogeneous mixture, right, in the homogeneous mixture we have to supply, right, we have to supply either the lean mixture, right? So if it is in lean mixture, right, if it is we are supplying the lean mixture means surely it will be burns easily, right? Surely it will be burns easily, right? So if it is we are using the lean mixture, surely we can get the low emissions, ultra low emissions we get. So automatically what will happen? The NOx condition will be reduces here, right? So here the NOx condition will be reduces. So here we can get only the hydrocarbon emissions, right? Only the hydrocarbon emissions and carbon monoxide and some carbon dioxide emissions will be produced here, right? So here we are not using any spark plug or the fuel injector, right? So if we are using the spark plug or fuel injector, then we can get the hot flame region. In that hot flame region we can get the NOx condition, right? So emission will be somewhat high. But in this HCCI engine, right, in this HCCI engine we are not using any spark plug or nor the fuel injector, right? So here the flame propagation, hot flame propagation will not be there, right? So at what we have to give this type of engine, mean we have to give some lean mixtures, right? We have to give some lean mixtures, right? So what will happen if the lean mixture will be compressed? So that lean mixture it will be easily auto
யார் இல்ல ஆனா ரெக்கார்டிங் எப்படி ஆகும்? ஹலோ, உள்ள போவோம். நீ ஏறா யாருன்னா சாருக்கு மெசேஜ் பண்ணுங்கடா. நான் பண்ணிட்டேன்.
பண்ணியாச்சுடா.
அது
மெசேஜ் பண்ணியாச்சுடா.
ஓகே. சார் ஆன்லைன்லயே இல்லடா.
Students?